All right, so the last thing to talk about in Module 7 is solving quadratic real-world problems. We've seen these before. Like I said, when you jump up and down, you form a quadratic graph. When you shoot a basketball, when you throw something out of a window, when you throw basically anything or jump, you're going to have a quadratic parabola, okay, with distance and time. So something's probably going to go up, and then it's going to come back down due to gravity, okay? So pretty much every single real-world problem we're going to be doing is going to have an a of a negative because it's going to be an opening down due to gravity. All right, so let's look at David Letterman. He used to host a late-night show, and they are throwing bowling balls outside of a window to destruct this car, okay?
It's all right. I just fine-tune your aim here. It's okay. That should do something. All right. Keep going. That's the windshield. Anytime you're ready. Oh, okay. Maybe could you use some rosin, maybe? Bob, you guys.
All right, so when you're throwing something out of a window, like we heard in this case, when you're throwing a bowling ball, okay, you're obviously going to hit something, okay? And so that hitting of the car in our video is going to be an x-intercept, okay? So that's what we've been doing with this module. We're solving for the x-intercepts. We're trying to find where something hits, okay? Also, some other things, the max height of the ball. So the highest part when she was throwing it out of the window, okay? So we're going to kind of talk about this example of Miss Callahan throwing a ball out of a window. Let's assume that I was 190 feet above the ground, kind of as tall as they were when they were throwing the bowling balls. And the pathway can be given by the equation where h is the height of the ball after t seconds. So here's our equation that represents me throwing a bowling ball out of a window. Okay, and I'm trying to figure out what is the ball's maximum height. So first thing, you need to kind of know your vocabulary. So max height we know is going to be the vertex. Okay. Now, this form is in standard form, which means it's not in vertex form. I can't find the vertex really easy. So if you remember, to find the vertex, you need to do this equation, which is x equals negative b over 2a. So that's coming back. So we're trying to find the vertex. So first off, your a is a negative 16, your b is 64, and then our c is 190. So again, our y-intercept would be at the very end, so it's where I'm standing before I throw the bowling ball. So let's find the axis of symmetry so we can find the vertex. So I'm going to start off with negative 64, since my b was positive. I'm going to opposite b, over 2 times negative 16. Now again, you can type that in the calculator in the fraction button, or you could simplify the denominator and get negative 32, and then have negative 64 on top. When you divide those numbers, negative divided by negative is positive, so you should get x equals a positive 2. Okay, so what that means is my ball is going to reach its max height somewhere at 2 seconds. Okay, but I don't know how tall it is, right? I need to find the whole part of the vertex. So pretty much I know 2, and I'm trying to find the height. Now remember, with standard form, to find the height, you're going to have to plug it back into your equation. So I'm going to take 2 and plug it in everywhere I see a time, which would be t. So let's walk through that. I would type negative 16, 2 squared, plus 64, parentheses 2, and then I'm going to add 190. Okay, so once you type that in the calculator, just how it looks, go ahead and do that. You should get 254. So again, if you need some extra help on how to substitute a variable in, let me know. But 254 is going to be the highest point, and let's say our units are feet. So 254 feet is going to be the max height that that ball reaches, okay? So basically, if I wanted to label it on a graph, here would be 254. So at 2 seconds, that ball reaches its max height, okay? So if I ask you for max height or vertex or anything like that, you're going to have to do negative b over 2a and substitute it back in. So now it wants to know when's the ball going to hit the ground. So first off, that's going to be what vocab word? Hitting the ground would be the x-intercepts. Okay, and that is when you solve something. So this whole module has been where we find our x-intercepts, where it crosses the x-axis, where x is a 0. So looking at this equation, that's not nice and easy to do the t-chart and factor because those would be huge numbers. So I'm not going to factor. Then my other two options are square roots, and since I've got 3 terms, I can't do the solving by a square root. So that means I'm going to have to do the quadratic formula. So I'm going to have to do the whole Soldier Boy x equals negative b plus or minus square root song. Okay, so let me go ahead and write that. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. 2a, okay. So I need to find a, b, and c, which I already did up here. And then I need to plug that into my calculator. So let's walk through setting it up, and then we'll go over how to plug it in the calculator. So x equals negative 64 plus or minus square root b squared, so 64 squared, minus 4 times a, negative 16, 4ac, 190. Everything divided by 2 times a, which is negative 16. So now I just have to type all of that into the calculator. Okay, so I'm going to do that with you guys right now. Trusty calculator. I'm going to cover it up a little bit. All right, so with our calculator, you need to hit the fraction button first. Because I can type this all in a fraction. So I'm going to hit the green button, I'm going to hit y equals, and then I'm going to hit enter. And I'm going to type everything in this top part into the calculator with a plus sign. So I'm going to start off negative 64 on top. I'm going to do plus. To hit the square root button, it's the second x squared button. And then parentheses 64 squared minus 4 times negative 16 times 190. And close it off. So I've typed everything in that top part. Hit the down button, and I just need to put 2 times negative 16. Okay? So you hit enter, and you get one answer is negative 1.9. So 1.98. Now, that does not make any sense because I can't have negative time. So that one does not work. So I need to do this again, but with the minus sign. So a shortcut is if you go up to your example problem and you hit enter. It's going to come back up exactly how you put it. Now if you scroll with this left button all the way to change that plus sign out front to a minus sign, you don't have to type all that in again. You hit enter and you get the second root or a solution. So the other answer is x equals 5.98. And that makes sense because you can have positive seconds. Okay? So that ball is going to hit the ground at approximately 6 seconds. You could say 5.98 seconds, doesn't really matter. Okay? So that is how you use your calculator for a shortcut on saving time with that quadratic formula. Okay. All right. Lastly, it wants me to find the height of the ball when t is half a second. So all that means is substitute it back into our equation. So I know half a second is the same as 0.5. So what I'm going to do is plug in 0.5 everywhere I had the t. So plus 64 times 0.5 plus 190. Okay, so all I'm doing is substituting my time into my equation. When you type that in the calculator, you should get 218. So what that means is at half a second, that ball is at 218 feet in the air. Okay, so you can kind of use your equation to figure out any time that ball is in the air. Okay, so those are real world problems. Again, they're a little bit confusing because you've got to know your vocab and how to solve it, but that is how you do it. We're going to do one more problem that does not have an A term, or a B term, sorry. So notice this equation is a little bit different. I don't have a middle term, so that's the same thing as saying negative 16t squared plus 0t plus 144. So that's a way of writing it, but again, if you don't have a t, they're not going to write it. So to find the max height, remember you need the vertex, which means I need to do x equals negative b over 2a. So here's my a, my b, and my c. So notice I don't have a b. So I'm going to have 0 divided by 2 times negative 16. Now 0 divided by anything is 0. Okay, so what that tells me is my vertex is on the y-axis. So what that means is your highest point is on this y-axis and x-axis. So basically your ball is going to drop straight down. So that's what happens when you don't have a middle term. But again, to find the other part of your vertex, how tall it is, you're going to have to plug in 0 here and just once actually. Okay, so I'm going to say negative 16 times 0 squared plus 144. Okay, again, 0 times anything is 0. So you're left with 144. So the ball's max height is going to be 144 feet. So a shortcut is when you don't have a middle term, your max height is going to be your y-intercept. Okay. When would the ball hit the ground? So again, that is somewhere over here. So we're looking for the x-intercepts. Okay. You can solve it using the quadratic formula. You can solve it by factoring, or you can solve it by taking the square root. Now, when you don't have a middle term, solving by taking the square root is the quickest way. So what you're going to do is set it equal to 0 and solve for t. You're solving for the time. So real quickly, subtract 144 and get negative 16t squared equals negative 144. Got to get t by itself by dividing by negative 16. So t squared is going to equal 9. Lastly, take the square root. So t is going to equal a plus or a minus 3. Now again, negative 3 seconds does not make sense. So you're going to go with the positive answer for a real world problem. So 3 seconds is when the ball is going to hit the ground. Okay. Lastly, again, this question wanted to know the height of the ball at half a second. That is when you just substitute in 1/2, or you could substitute in 0.5. So go ahead and plug in 0.5 for t. 144. Once you plug that in, you should get 140 feet. Okay. So anytime it wants you to find the height of an object at a certain time, just substitute that time back into your equation. Okay, so that's how you find when something hits the ground or the max height of a ball or an object using your knowledge of quadratic formula and your knowledge of axis of symmetry. Okay, thanks for watching. Let me know if you have any questions.